let's see here. So I'm just looking at the test study guide. I have a quiz tomorrow, and I'm just using the test.
We ended yesterday on quadratics, factoring, correct?
I'm not entirely sure what the learning target was.
What's that?
I know we ended on we were simplifying radicals, but
Oh, okay. Well, do you know what you want to cover today?
yes. Let's go over. Okay, so
Is it something you can verbalize?
yeah, I'm just gonna go with one that I really don't know at all,
Okay.
and it's gonna be I can compose two functions and find the domain of the composition.
Okay.
And so it says find h of x and state the domain. And then h of x is going to be 5x to the negative first power.
Hold on a second. H of x is 5x to the negative 1, okay? And they want you to find h of x?
Yes.
Okay. So, let me teach you some real fundamentals here. First of all, let's write that as what? What's another way to write that if I don't want a negative exponent?
I know
What's
the
a negative
fraction
exponent mean?
that you flipped the so it's like
5 over x. The negative 1 does not apply to the 5. It only applies to the x.
Okay.
Okay? Now, if I said to you, what is h of 10? What's the answer?
1/2.
No, plug in 10 for x.
5/10, which is 1/2.
Oh, I'm sorry. I didn't hear you say 1/2. My
It's okay.
apologies. Okay? So, the rules are whatever you put in the parentheses, you plug in for x. That's the only rule you need to remember. Okay? So now they want, what is h of x? Like that. Well, what is h of x? It's 5 over x, right?
Yeah.
So now, what is h of 5 over x? How do we solve that? What are we going to do? We're going to plug in whatever's in the parentheses.
To as x.
Okay, so into here, we want to plug in 5 over x for x. So this becomes 5 over, and instead of x, we're going to do this.
What the heck?
Now hold on, just look exactly what I'm doing. I'm taking whatever's in the parentheses, and I'm plugging it in for x. Well, there's 5, there's x. There's 5, there's x.
So it's already that's the answer.
Well, no. Now you have to figure out how to do that math. How do you divide by a fraction, which is what we're doing here?
I'm not too familiar with dividing by a fraction.
Flip the bottom and multiply. In other words, you never divide by a fraction. You always flip it and multiply. So this whole thing is equal to 5 times x over 5. 5's cancel. That's equal to x.
Okay.
Hold on. I don't want to leave the subject. You're a little. Divide 2/3 by 3/4.
So it's going to be 2/3 times 4/3, which the threes are, it's going to stay the same, and then it's going to be 8/3.
No, when you're multiplying, you multiply both.
Okay, so 8/9.
It's only when you're adding. If I was adding 2/3 to 4/3, it would be 6/3. But when you are multiplying, you multiply numerators and you multiply denominators.
Okay.
Okay? So 8/9 is correct, and it simplifies those kind of problems immensely. Well, here's what we were looking at. Now, the one thing that gets confusing here is where is the main fraction bar? Well, the main fraction bar is that long one. Okay, this one. So if I'm going to flip and multiply, then it's going to be the numerator times the denominator flipped. Now the 5's cancel and I'm left with x. Okay?
Okay.
All right, what else?
All right, let's see.
Similar problem, hopefully, because that one was a little tricky, but they're never tricky if you just always follow the rules. The rules being whatever's in the parentheses, you plug in for x. That's the rule.
Okay.
Give me another one.
It's a big word problem, so I don't know how well you're going to be able to help me out with it. But it says, let x represent the original cost of a pair of jeans. You have received.
Okay, that's my first step on all word problems, is to define your variables. Okay, go ahead.
Okay. You have received a $5 off coupon in the mail.
Okay.
F of x represent the total cost of jeans after applying the coupon.
Okay. So.
And then there's another couple sentences.
Okay, well, let's handle this one first. Let f of x represent the cost of the jean after the coupon. So it's going to be x what?
Minus 5.
Right. So that is f of x. Okay, keep going.
The store is also running a 25% off sale. Let g of x represent the total cost of jeans after the sale.
And the coupon still applies?
Yes, it's the store is running a 25% off. So would that be, how would you?
Well, instead of x, what are you going to pay if they're taking a 25% off?
75% of x?
Exactly. 0.75x is your new cost. In other words, if the jeans were $100 and they're taking 25% off, they're taking $25 off. So you're left with the complement from 100. So that's the cost of the jeans with the 25% discount. And assuming we still get to apply our $5 coupon, which I guess we do, always, right? I mean, unless they're two separate problems, but if they send it to us in the mail, we still have it.
So it put x as it's actually saying like what our f of x and g of x should be. F of x is x minus 5 and g of x is 3x over 4.
Ah, okay. So hold on a second.
And so it's 3/4 x.
Well, we know that that's what it is right there. And what are they saying it is also? G of x, what's the function they're giving you?
3x over 4.
Ah, notice what that is. That's just the 25% discount. That's the same as 0.75x. So
yeah,
if they're telling you that's what g of x is, then the coupon doesn't apply.
Yeah.
G of x is just 3x over 4. Okay, what's the next question on this problem?
Find g of f of x.
Okay. Here, let me erase some stuff here so I have room.
And we could spend the whole rest of the time on this problem because it has an A,
We don't
B.
really need to. These are not, oh, you got someplace you got to go? These are not hard. They want to know what? G of f of x?
Yes. I
Okay.
do have to go at 530, but I'm saying is that this has multiple steps to like the problem, and then it's going to want us to find f
That's
g of
fine.
f of 36. And
They're still not hard. So
okay,
what am I going to put in there in the parentheses?
you're going to put f of x, which is x minus 5.
Okay. Now what am I going to do with the parentheses? What's inside the G parentheses?
3x.
Yes, I'm going to plug it into this function right here, actually this function. In other words, I've got to use the G function. I can't use the F function. I got to use the G function.
It's going to be 3x minus 5 over 4, right?
Well, first thing I'm going to do is plug in 3/4 x for x. Now I'm going to subtract 5 for it. There's your answer.
Okay, so
In other words, the rule says that, hold on a second, I did this wrong. Sorry, just a second. Let me fix it real quick. The rule says is that I'm going to plug x minus 5 into the G function. So let's write it like that. It's 3 times x minus 5 all over 4.
yeah.
Okay, and then that does simplify to 3x minus 15 all over 4. And that is an acceptable answer.
Okay.
You could also split that into two fractions, so it's 3x over 4 minus 15 over 4.
Yeah.
Either answer is correct. Okay, and now they want f of g of x.
Yes.
Okay, let's erase this one.
Wait, no, they want g of f of 36.
Okay. They want, I shouldn't have erased it. G of f of 36. Always start from the inside. What's f of 36 equal to?
31.
Okay, so it's really g of 31, right?
Yeah.
Okay, now keep going. What's g of 31?
31 times 3, which is 63 over 4.
31 times 3 is 90.
Oh, yeah. 93 over 4. I'm sorry.
No problem.
This is the calculator section, so we should be fine when I get to that point.
Okay. So this is how you do all of these composite functions. They really are quite simple, as long as you don't get confused by all of the strange parentheses and terminology.
Yeah.
You just have to do it step by step and always start in the middle. In other words, I'm going to figure out what f of 36 is because I can do that really easily. And then that's a number, so I'm going to substitute the number there. And now figuring out g of 31 is real easy. Any other parts to that problem?
Yes, it wants to know what does f of 36 represent?
Okay. They've used 36 in place of x. So what is 36 going to represent?
The amount of pairs of genes?
No, the cost of a pair of genes. Remember,
Oh.
that's what x is. That's why I write it out. And it's a good idea to always write it out. Because it could be a couple of things. It could be the cost of a pair of genes, or it could be the numbers of pair of genes that one has. So it's really important to put that description on it right there. It is the cost of a pair of genes. So f of 36 means x is 36, so the cost of the genes is 36. So f of 36 is 31 because you get to apply your $5 coupon. Okay, what else?
Okay. All right, so you're going to want to erase everything because it's a totally different.
Okay.
The learning target is I can solve equations using properties of radicals and rational exponents.
Okay.
And the problem is x minus 8 equals a square root of x minus 6.
Like that?
And then check for extraneous.
Yes. There are three kinds of things that if you see in an equation, there's a high likelihood that you'll have an extraneous solution. Okay? One of them is radical signs. The other is absolute value signs, and the third one is logs. If you see any of those three symbols in an equation, very likely you're going to have an extraneous solution. Not always, but frequently. So how do we solve this?
What are logs, though?
Don't need logs to solve this.
Okay.
And logs are a big topic. We would need a solid half hour for me to explain logs to you.
Okay. So, well, I would say...
Got to get rid of that radical sign. How do you get rid of that radical?
That's the first step.
What's the first step?
Don't you take the...
You can square both sides.
Yeah, that's what I was...
When you square a radical, you're left over with whatever was in the side of that radical.
Yeah.
So usually when you have a radical sign, isolate it and square both sides. Now, what's the left side squared? Got to FOIL it.
X squared. Oh wait, so you've got x squared.
The biggest mistake in algebra is saying x squared minus 64. It's not that. Remember what you're doing. You're taking x minus 8 and you're multiplying it by x minus 8. So you got to FOIL that.
Okay. So x minus 8 times x minus 8. So we've got x times x, which is...
That's where I got my x squared.
Okay. And then we have... we've got 64, positive 64.
Okay, that's the last term.
Okay. Then we have negative 8x.
Twice.
Yeah, twice.
Negative 8x, and you got another negative 8x. You got negative 16x. Now, keep going. We still got to solve this. We're going to end up with a quadratic. But how do you solve a quadratic? You get everything on one side, you get 0 on the other. Which side are we going to put everything on?
The left side?
We'll start with getting rid of that x over on the right side.
Okay, so would we subtract it?
Okay, so what does that make? Instead of 16, negative 16x, negative 17x, okay.
And then add 6 on both sides, we get 70.
Okay.
Equals 0.
Now, this is one of those elementary quadratics, which is 90% of the ones you're going to have to do. The number of times you'll have to do where it has a number other than 1, it's hardly worth the effort to do it. When we have time sometime, I'd be happy to teach you. But it's a lengthier process. So let's go through the method we worked on yesterday. 3-step method. First step.
Put the x's in.
Split up the x squared. You split it up by that, because I know that x times x is equal to x squared. Second step.
We get the factors of...
Nope, everybody skips the second step. That's why everybody has problems. Don't skip my second step, and you won't have any problems at all on these. Second step is determine both signs.
Okay, so it has to be a negative times a positive because it's going to...
The thing you focus on is this sign right there. There's only one way you can produce a plus 70. And that's if both signs are the same.
Okay.
In other words, if it's plus plus, then the last term is going to be a plus. If it's minus minus, the last term is going to be a plus. If it's plus minus, then this is going to be a negative 70. So
Yeah.
that plus sign right there tells you that both signs have to be the same. That negative sign tells you they both have to be negative. Real simple. It's just a two-step process to figure out both signs. Now, do your third step that you tried to do second. Factors of...
Well, the positive sign tells you that they both have to be the same sign.
That plus sign does, yes. Tells you both sides have to be the same. And to figure out whether it's plus plus or minus minus, you look to the middle term.
Okay.
That's the middle term is minus. We know it's
They
minus.
have to add together to 17, but have to multiply to 70.
Correct. When you say factors of 70, that's why I like students to verbalize it properly. Factors of 70 means two numbers that multiply to 70.
Yeah.
So what two numbers that multiply to 70 add to 17?
7 and 10.
And it doesn't matter where I put the 10 or where I put the 7.
Nope, not in this case.
So now, not in this case. Sometimes it does. If they're different signs, it's going to matter. So what are my two solutions to this?
X equals 7, and then X equals 10.
Okay, now, in order to determine whether we have an extraneous solution, let's plug it in. Okay, here was our original equation. Does 7 work?
7 minus 8 equals negative 1. 7 minus 6 equals negative 1 squared.
No. It's the square root of positive 1. If you plug in 7 for x, you get the square root of 1. What's the square root of 1?
1.
Those two that's not an equation anymore, is it?
No.
That means that doesn't work. Does 10 work?
10 minus 8 is 2. 10 minus 6 is 4. Square root. Oh, there. Yeah, it works.
Okay, one of them always works.
So 10 is the extraneous solution?
No, 10 is the correct solution. 10 is the only solution.
Okay.
The extraneous means the solution that we got, but isn't actually a solution. That's what that means. It's the wrong solution. We came up with x minus x equals 7 by solving that quadratic.
Yeah.
There's one thing in algebra. When you have two numbers multiplied together, that one, and they're equal to 0, it doesn't say both of them have to be 0. It just says one of them has to be 0. Well, in this case, this is the one that was 0 by x being equal to 10. X equaling 7 is not a solution to this thing.
Mm-hmm.
Because I got 1 equal negative 1.
Yeah.
Okay. You got another one of these? We can do it real quick.
I don't have any ones that would be fast.
Okay. You could.
Thank you so much. Yeah.
Okay.
Thank you.
Remember those 3 steps on solving those quadratics. That's huge. Don't forget that second step. Everybody forgets it. Wish I had it.
Okay, thank you so much.
You're welcome, Nick. And talk to you next time. Bye-bye.
All right.